Good morning, Math 8 students. Mr. Frechette coming back at you. I got to clear up my calculator. It's Wednesday, March 18th. I hope everybody had a great St. Patrick's Day. And everybody is safe and well. I saw a lot of comments on Google Classroom, and it's good to know that you guys are chiming in and asking questions and having some time to do your math work as well. So I'm actually set up in like a makeshift like an altered office in my house doing all this and these videos. So, it's been interesting. I definitely have to get really creative. So, but that's good. It's good to have, to encounter problems and different things because you got to solve them, right? So, what are you looking at today? You're looking at a picture of my backyard. Crazy, isn't it? It's actually, we're getting to spring. I had some time to get out there and do some, do some work, do some raking and different things. In between doing schoolwork and other stuff. So this is actually a picture of my pool covered up. If you can see, you got all that water on top, and if you look really closely, that shadow right there is the leaves that have collected over the winter, the fall and the winter. So that's what's happening there. But today we're going to talk about volume because we were talking about calculating volume, but we first started with some review with area problems, and then we talked a little bit about perimeter and what perimeter is, the distance around the outside of an object, obviously adding up all those sides. But today we're really going to jump into volume, and we're going to look at a volume of a cylinder. This is considered a cylinder. So when you look at this is a cylinder. So what I'm going to do first is, Mr. Frechette's pool has certain dimensions, and we got to look at those dimensions in order for us to figure out the volume of this pool. So let's look at some of the dimensions. So first things first is our height, or also known as our depth. The height of this pool is simply 4 feet. Okay, that wall is 4 feet. Okay, there's one other thing that you need to know. I'm going to point this out with a red marker. Right here in the center, okay, the depth or the height in the center of the pool is actually 5 feet. So, that's going to change something because we actually have to calculate an average to help us in our formula to figure out what the actual volume is. So I'm just going to put 5 feet right here, and then we'll calculate an average going through, and that is a nasty looking 5. I'm kind of doing this with my mouse. I have a touch screen laptop, but it's, it's not working with my pen and different things and with the screencast. So that's the best 5 I can draw. I know it looks like a crazy looking S, but that is actually 5 feet. There's a couple other things we need to find out. So I'm going to draw this in green. We need to find out the diameter. So the diameter of this pool, if we go all the way across, and my line's not looking very good, I'm going through the 5 and everything else. It is actually 24 feet. So we're going to put in 24 feet right here. Well, that 2's not too bad, I guess. So 24 feet, right? So we have 24 feet. And one other thing we need to know the radius. So the radius, I'll do that in black, it's half of the actual diameter. So even if we did it this way, it would measure 24 feet. So it's not going to make a difference. This is a round pool. So half of 24 we know is 12. So the radius itself is 12 feet. Okay? So we have 12 feet. Now, the formula is the next thing. What is the formula for calculating the volume of a cylinder? Well, the volume of a cylinder is V equals pi. And we'll get to the pi button in a minute. It's right on you can get a pi button through any kind of calculator, or even your phone calculator, I believe, has it. There's different resources online where you can get the pi button. So pi r squared, right? And that's times the height, or in our case, the depth of the pool, right? How deep it is. So that is our formula. So we're just gonna plug in some numbers that we have, and then I'll mention something else before we calculate how much water this pool can hold, or in our case, the volume. So volume equals pi. So you're going to put in pi. pi we know is 3.14. We just talked about that. 3.14 ... It's an irrational number. It goes on forever. It doesn't have a specific pattern, and no one has ever proven it to be a number that eventually stops. It just goes on forever, right? To infinity and beyond, as Buzz Lightyear would say. So our radius in this case is 12 feet. So I'm going to put parentheses here. I'm going to put in a 12, and then get that tail on that too. All right. That doesn't look like a parenthesis. It looks like a bar. All right, that'll work. And then our height. We don't know our height yet, but I told you it's 5 and 4. So the only way we can figure out an average is take 5. And I'm going to use a calculator if you look at the screen below. Do 5 plus 4. Oh, why did it do that? So 5 plus 4 equals 9, and we divide that by 2 because we have 2 data points, and our average is 4.5. So we're going to end up multiplying this by 4.5 because that is the average depth or the average height of the pool. And the next thing we'll have to do is, dabble into the calculator. Oh, that's a better 5, isn't it? Okay, so down here, I'm going to bring my volume in. See how I'm working from top to bottom. And I should get less and less work as I go down. Showing your work, like I said before, is critical. It's crucial. It's important. So pi, right? So in this case, what I like to do is order of operations. PEMDAS tells us, we don't have any parentheses, but we do have exponents. So we got to take care of our exponent first, right? And we know that 12 squared, right? We can put it in our calculator. I want to put it in my calculator, but that's obviously a perfect square. So I seem to know it. I know it being a math teacher and all, but most of you guys probably know it too. But it's 144. So when I put that in, I get 144. So I have pi times 144. And we're going to put this all in our calculator in a second. And that's also going to be times our 4.5. Yikes. Times 4.5. Wow, that's tough writing on here. So, I'm putting an equal in there. We got 144. So let's start out with this. We have pi. I'm going to hit my pi button. I'm going to multiply that by 144. And I'm going to multiply that by my average depth or my average height. And I get 2035.75. We can round it to the nearest whole number. Let's go 2036. So we got 2000. And actually, you know what? Let me erase this. I want it to look a little bit better than that. It's a lot easier when you have your touch screen at school. So let's go back to our marker. Click on that. I'm going to move over here just a little bit. Give me a little more space. So volume equals 2036. And that's feet cubed. Because we're dealing with cubic feet. So we have 2036. A lot tougher than I thought. And we'll go, got our little F, got our T, and that's feet raised to the third power because we're dealing with 3 dimensions. Okay, so we have that. I'm going to put my comment in here. We're not done yet, though. We have the volume, but the question is how much water or how many gallons will this pool hold? Like I said before, we have a 24-foot pool, a radius of 12 feet, and an average depth of 4.5 feet. So gallons, how many gallons does this pool hold? Well, the rule of thumb is there's 7.5 gallons per cubic foot. So what we have to do is, to figure out how many gallons go into this pool, we got to take 2,036, and we have to multiply that by 7.5. And that should give us 15,270 gallons. So in terms of what this pool can hold, my pool can hold 15,270 gallons. So think of a gallon of milk. Think of having 15,270 of those lined up in my backyard. And then in order to fill that pool to the top, which I don't usually do, you would have to put all 15,270 milk gallon containers full of water into my pool. So this is a good way to learn volume. This is a real life thing. So, I know that that's the amount of water I would need. And then, obviously we could look at different things. How much would that cost? How much would it cost me to fill my pool? In terms of my water bill, what would that change? But, that's something we can obviously talk about later. So, everybody have a great day. And I hope you enjoyed this video. And, I'll be tuning in on Google Classroom through Mrs. McKeech's classroom, Mrs. Dombrowski's classroom, and then I'll be giving you some YouTube channel stuff as well, going through. So everybody have a great day, stay safe, be well, and I hope to be back in the classroom with all of you guys very soon. Okay, take care.